All right, for today's lesson, we're working on 3.7, and that is on factors, multiples, and decomposing numbers. So what I want to do is just give us a quick refresher on how we do that. So we're going to start by decomposing a number. We're going to decompose the number 12. Okay, so when I say decompose, that means that I want to find all of the factors for that number. So the first thing I know is that every single number ever has the same one factor, and that is the number 1. So what I like to do is I like to write my number 1 on this side. Okay, now I know that what is another factor is I have to think, what can I multiply by 1 to equal 12? If I think back to when we talked about rules of multiplication, I know that I have the identity rule of multiplication, and that tells me that anything times 1 is that same number. So what this tells me is that 12 times 1 is going to equal 12. So I'm going to put 12 on my other side. Now I know that all of my possible factors, I'm decomposing it, are going to come between 1 and 12. Okay, so I work my way up. Now my next one, after 1, I'm only using whole numbers, so my next number that comes up is 2. I know that if 2 works, my number is going to be even. So if the number is even, 2 is going to work. If it's odd, 2 won't work. So I'm going to think to myself, the number 12, is that even or odd? I know that 12 is an even number, so I know that 2 will work. And now I need to think to myself, what times 2 is going to get me to 12? So I can think maybe 5, but I know 5 times 2 is 10. So I'm going to count by 2's for this one to kind of help me with that 2's fact. So I got 2, 4, 6, 8, 10, and 12. So if I look, I have 6 fingers I'm holding up. So that tells me that 2 times 6 equals 12. When I decompose it now, I'm working. And now my new number, instead of being between 1 and 12, now I only have to look between 2 and 6. Right? So now I'm going to think, my next number that comes up is 3. So I'm going to give 3 a try. All right? And I'm going to again use my skip counting to see if I can get. So if I know my facts right away, that will really help me with this. But if I don't know my facts, I'm going to go by my skip counting. So I know that I have 3. 3 plus 3 is 6. 3 plus 6 is 9. 3 plus 9 is 12. And I know that I just reached 12. And since my skip count here, I can go 1, 2, 3, and 4. Since I added 3 4 times, I'll slide up a little bit there. Since I added 3 4 times, I know that 3 times 4 is going to get me 12. All right, now I look. There is no whole number between 3 and 4, so what that tells me is that I have completed my decomposition. I found all of my factors. All right, so when I'm decomposing a number again, I'm always starting with 1 because 1 is a factor of every number. And then I also start with the same number itself because 1 times 12 is going to always be 12. 1 times 15 would always be 15, and so on. So I always use that identitive property of multiplication. Then I'm just shrinking them down slowly until I have all of my factors. This one that's going to come up on this is multiple. Okay, and a multiple tells me that it is the product of any number and a whole number. And what that means is that when I'm looking for multiples, I'm doing a lot of different multiplications. So if I want to find, like some of these will say your first 5 multiples of, let's say, the number 5. All right, so what I'm doing is I'm actually doing multiplication problems. So my first 5 would be like 5 times 1. Well, 5 times 1, I know that identitive property of multiplication is 5. So that would be a multiple of 5. I can keep going. My first 5, I'm going 5 times 2. 5 times 2 I know is 5, 10 by counting by my 5, so 10. That would be my second multiple. So again, you're seeing that when I'm finding multiples, I'm using this number. If I'm finding the multiples of 5, I'm using 5 in my problem. And then, depending on what I want to use, I'm just multiplying it by another whole number, and this ends up with multiples. Okay, so I can keep going. 5 times 3 equal 15. That's another multiple. And I can even go larger if I want. If I want 5 times 10, 5 times 10, if I count by my tens, I get 10, 20, 30, 40, 50. 50 would also be a multiple because, again, my multiples, my definition is a product. So these are my products because they're answers to a multiplication problem of a number. So since I start with this number, 5, that's the number I'm using, and any whole number. This is where it can really change, is this 1, 2, 3, 10, 100. Any whole number is going to work as long as I'm using my 5 that I'm finding the multiples of. All right, so another thing I can do with this is I can see if my number is a multiple. So what I want to do now is I'm going to think, is, let's say, 45 a multiple of 5? Okay, and when I do that, when I say, is 45 a multiple of 5, again, I'm going to use my definition. So my definition of a multiple, it tells me that I choose my number, I want to know, 5 times any whole number, and then is 45 going to be a product? So this is where I'm going to set up my fact families if I want, or I can solve it this way with trying my guess and check, but I like to use my fact family. So I know that if I want to switch this, again, my fact family tells us that I could have, my unknown, we'll use a question mark, times 5 equals 45. That doesn't really help me. That's the same problem, just kind of flip. But what I can do is I can set up a division problem. So I'll set up 45 divided by 5 equals question mark. And then I could go in and solve this and see. And if I get a answer of a whole number, I know that 45 would be a factor or a multiple of this number. So now that you've had a chance to kind of review what we learned in class yesterday, take time to go in and work through your homework.